Hey everyone, welcome back to the Piper Cherokee destruction videos. John here from FlightMikeAlpha.com. Today, we are talking systems knowledge. Alright, so we're back in the garage with the engine, ready to go ahead and pull what's left of our propeller off here. But a couple things we wanted to talk to you about before we actually do so. Take a look at these bolts holding on the propeller, okay? Notice a few marks on the bolts that are signs of wear and kind of bad things happening here. You can see another little shiny mark there. Something not quite right. We don't want sharp force applied to these bolts, and that's why we like to replace these bolts anytime we remove the propeller. Bolts are relatively cheap compared to, well, having your propeller come off in flight. Other things about our propeller you want to notice here, you've got a little number stamped on here. So you actually have your information for your serial number and what kind of prop it is stamped into it. And it'll tell you things like the overall diameter of the propeller as well as the pitch of the blade. Now, it's important to note that just because it has a certain thing stamped on here telling us the overall diameter and the pitch, well, people could have filed this down over time. Obviously, this one's a little bit shorter than it used to be. And they can also twist the blades or bend the blades to change the overall pitch of the propeller, or in other words, the pitch is how big a bite of air the propeller takes at a time. Given that this is a fixed pitch propeller, you can actually twist the blades and fix the pitch setting to a different setting compared to a constant speed prop where the pitch is a range. This is going to be a fixed pitch propeller and it will have a number stamped on there. Back to these bolts. You can see that they are long, they're shouldered, because we want the bolt to be smooth where it's bearing the load, not where there's threads. And the threads are a place that they can wear, especially if you drop this bolt, you don't want to put it back in there. If the threads are all messed up and you put this back in, you're putting into the receptacle, into the threaded hole, into the crankshaft. With bad threads, you're going to mess up the threads on the crankshaft. The crankshaft is really expensive. Upwards of $8,000, not to mention the fact that you have to remove the whole engine and split the case to actually get to it to replace it if you were to muck up those threads inside there. So, whenever you can, replace the propeller bolts with fresh propeller bolts. Also notice how the head is drilled out there, how there's a hole in the middle, and that's for the safety wire to go ahead and run through these bolts, because obviously if these bolts came off, it'd be really bad. Even if they just loosen, it's really bad. We want not only the bolt to bear the sideways load of that propeller, we don't really want that to happen. We want this bolt to work the way it's designed to, which is in tension. To pull apart this bolt is much more force than to shear the bolt. So we don't want a shear load on these bolts. We actually want these bolts to pull the propeller tight to this flywheel and tight to the crankshaft to actually create friction between all of that. So when the crankshaft is turning, friction is driving the propeller as well as the actual shear load of the bolt. We don't want it to purely be shear load, we really want that tension load, that bolt pulling this prop into the crankshaft to hold it on tight, so we're not putting a side load on those bolts. Let's get rid of these bolts and let's get rid of this prop. And last one. Now, why do we throw things and bang things around and make all those weird noises? Because I want you guys to start to understand how all these different pieces of metal make different noises when they clank and bang and rattle around on you. So, when you hear those weird clanking, banging, rattling sounds when you're flying your airplane, you kind of know what that sound might be. You can make an educated guess as to what that might be. We'll go ahead and wiggle our prop off here. And the propeller is coming right off of the actual crankshaft there. We'll set this guy down. Not very gently, but that's what it sounds like when the prop hits the concrete, in case you were wondering. So what we have here is our flywheel, our flex plate, what I would call it from the automotive world. Obviously, it's not what we call it in aviation. And it's this aluminum piece here. Sounds like aluminum. It's not magnetic. Oh, there goes our magnet. And it's obviously rather brittle, right? So what normally happens here, what Lycoming actually calls this, they don't call it a flex plate or a flywheel, they call this a starter ring gear support. So this is our starter ring gear support and this is our starter ring gear. So the job of the ring gear is to actually interface here with the starter, and when you press that start button or turn the key to start, this actually slides out. You can see how that would then interface with this ring gear here. Now, because well, this engine was very heavy and I might have kind of dropped it out of the back of the truck and it hit the pavement, well, this all cracked. Now, had I not done that, this might actually be intact here. But the whole idea, you can see how this ring gear would normally be here and it would come out. Now, how important is this ring gear really? So it's its own individual part. You can replace just the ring gear. As you can see, it separates from the starter ring gear support, this aluminum piece that's on our crankshaft. So to answer our typical questions that we want to answer, can we fly without this? Well, I guess once the engine's running, the engine would continue to run. We use this just to start the engine. What's the failure modes and how does this typically wear out? Well, we typically start missing teeth or getting the teeth to become very worn. And any wear or missing teeth here can also mess up the pinion gear down here on our actual starter itself. So it's rather important to make sure that the teeth on the starter pinion are good, as well as this overall ring gear here. If you ever do encounter an airplane where you're missing a tooth or two, or you see where the teeth are substantially worn, definitely bring that to the attention of the mechanic. Some people have the attitude of, it's just missing a tooth or two, so you just kind of hit that starter and bump it again, or maybe move the prop by hand a little bit to get it to line up to where it's going to engage with some teeth, and then it'll get going. That's going to do a lot of damage to the starter. It's not going to be good for the engine overall. It's not going to be good for these gears at all, and it's just plain not really safe or airworthy. So that's a steel part, by the way, if you're wondering. And what we're left with here is what I would call a flywheel, but it's not called that by Lycoming anyways. And why I call it a flywheel is because it's bolted right to the crankshaft. And on the back side here, you're going to see that is where our alternator belt is. So we can see the back side here, the alternator belt goes in there. It's a V belt, so we kind of have a little bit of a V channel running right in there. And that's where that belt rides. And this is a part that comes off. Obviously you can replace just this one part. We can see it's nice and cracked up and corroded from it falling out of the truck and then all those years sitting out there in the salt. And there's our alternator belt. So to actually change the alternator belt on an engine or on an airplane, you're really going to need to remove the propeller, because how else will you get the belt over all of this assembly here and over the propeller, most importantly. So what you'll see in Alaska, what people do, and out in the bush and other places, they'll actually take an alternator belt, not that this is necessarily legal, but it's what you'll see on some airplanes. If you ever see this and you're wondering why, they'll actually wrap the belt around the engine here, just like that, and they will then zip tie it to the engine, and they'll leave it just like that, a spare alternator belt. And you're like, why do you need a spare alternator belt there? Well, there's one, and then they would take the other one, and they would actually put it on the alternator, and then they would then put it on the flywheel, or the starter ring gear support, as Lycoming refers to it, and that would go ahead and function as your normal alternator belt. If this ever broke and you were somewhere very far from a place where it could be fixed, they would just simply remove it, just cut it out, or if it had already fallen off, they would just simply take the one that they had placed like so, and without having to remove the propeller, they could wiggle it down into place, slide it over the pulley, that is really the backside of that starter ring gear support, and slide it over this pulley right here, and then there you go. Without having to remove the propeller, you now have a belt to drive your alternator once again. Not exactly a STC modification there, but something you might encounter on some airplanes if you're wondering why there's an extra alternator belt zip tied onto the airplane like so. Well, that is the thought process that that person had when they did so. So, regular alternator belts, don't just go to Napa and buy one though. Actually get the FAA PMA approved part. They last a lot longer. And you can see on this belt how it is a bit of a V shape there. And that's just to give a little bit more contact area, a little bit more friction to drive the alternator while the engine is turning as well. And this alternator, well, doesn't spin too freely anymore. We'll get to the alternator here in a little bit. The next part we're really going to be looking at here, now we're looking at the front end of our crankshaft, by the way. So this is actually the crankshaft protruding out of the motor, and this is the front end of the crankshaft that would actually drive that propeller. And as I'm turning the crankshaft, all those internals on the engine are moving, whatever's not actually totally destroyed from when we burned up the engine without any oil. Next up, we're going to go ahead and remove our oil cooler here and take a look at the overall oil cooler assembly, and then we will go ahead and start removing some of the baffling to get a little bit better idea of what's going on around this engine and get a little bit better view. Well, it's not all covered up with all this baffling to just direct airflow. And of course, the purpose of the baffling, if you're not already familiar with it, if you're baffled at what the baffling is for, the baffling makes a nice tight seal with the cowling and then keeps the airflow forced to flow where it needs to, forcing the airflow through the cowling inlets, through the oil cooler, over the cooling fins on these cylinders, flowing down around the cylinders, keeping the cylinders cool, and eventually down to some ports back there that we'll take a look at later on, where that air is going to go perhaps into your carburetor heat or into your cabin to heat something, and so on. So next up, let's go ahead and start removing this oil cooler. Okay, now this guy's all loose here, so just those couple screws is all that was really holding on the baffling and holding on the oil cooler as well. You can even see some wear patterns here as we're looking right on this baffling, as that's been kind of chafing into the fins on the cylinder. That's not supposed to be that way, so that's actually wear patterns. Eventually that'll wear right on through this metal, and that's when you have to go ahead and replace your baffling. Now, before we rip all of this stuff off, we want to go ahead and take a look back here at what exactly is going on and where these scat tubes are going. So we can see, for starters, we have an opening, a little about 1.5 inch opening back there in our baffling. Where is that air going? What's it being used for? Well, it's this 2-inch scat line right here, and or 1.5 inch, man, I really can't tell. 1.5 inch, 2 inches, something like that. And this scat line is coming back here into, well, tucked away right in there. It's blowing air onto our fuel pump that is engine driven to keep it cool and keep our fuel cool and keep it from boiling. So we're going to go ahead and disconnect this scat tubing up here with a flathead screwdriver to free that up. And then you can also see where we have this little metal tube down there, about a 1/2 inch diameter. You guys can see in there. Hopefully the camera's aimed well enough. So that little 1/2 inch tube is this little 1/2 inch tube on the back of the baffling, just blowing a little bit of air right onto this magneto to keep this magneto cool, to keep that magneto from getting too hot. So that's some airflow just being jetted right out there to keep that magneto cool. That is the purpose of that guy. Let's go ahead and remove this flathead screw here. There we are. And wow, this stuff has not come off in a while. So, some things about scat tubing. It's this orange rubbery stuff, and that's all good, but it has steel windings inside of it that give it its strength so it doesn't collapse, and those steel windings can get awful rusty and eventually become brittle and break, and then you wind up with rusty bits of steel, metal being shot places it should not go. So good idea to replace scat tubing before it gets to this point where you squeeze it and it just totally fails and cracks and breaks and is really, really in bad shape there. So that part's all good. Let's go ahead and continue removing this baffling from here and getting our oil cooler freed up. Maybe we can go ahead and get this oil cooler off here now that can actually access these bolts and free them up from the baffling. Boy, that is very corroded. And in the meantime, to make our life a little bit easier, we're just going to go ahead and do a little bit of surgery here. And just kind of snip through some of this stuff to buy ourselves a little bit more space to work and see what's going on. Now, before we get too carried away here, I really wanted to take the time to actually show you guys what this propeller looks like, that cross section there of this propeller. So that is what you're looking at. And what it looks like a wing to me, and that's the idea, right? That is our propeller. That is just a wing spinning around. It has camber, it has that nice shape that your normal wing does on your actual airplane to generate lift. So it's just generating lift, pulling you forward, rather than generating lift vertically like the wing does. Next up, let's go ahead and take a look at this starter. So we can see right here, we've got our big heavy wire coming in. That's going to supply 12 volts right to the starter. In some cases supplying 24 volts, but this is a 12 volt airplane, 12 volt starter motor. You might be saying, well, gee, if there's 12 volts coming in, where does the 12 volts go out? So there's one big heavy wire coming in. Shouldn't there be a big heavy wire going out back to the battery to close that circuit to actually make electricity flow? And the answer to that is no. 12 volts comes in, goes through the motor, and then returns to the battery via ground, which is really grounding to the case. So the electricity is actually flowing back through the engine and then flowing through a grounding strap, or just by all this metal that's connected to the actual airframe itself. The airframe then transfers that electricity back to the battery, So it's very easy to get a bad ground somewhere along the way, and then electricity won't flow so well, and then your starter motor doesn't work quite as well. It's really hard to start the airplane. So whenever you do replace a starter, you always make sure that the surface between the starter motor and the engine itself is going to be free of any sort of corrosion or rust or anything like that. So you have a good contact, a good ground, and you want to make sure the whole thing is grounded well all the way back to the battery. You can always test that with a voltmeter and measure the ohm resistance. That's getting a little bit on a side topic we'll talk about later when we get to electricity, about the actual ohm resistance value to tell you how much resistance there is between here, this point, where it's going to be grounded, and all the way back to the battery. You do that with a DV-ohm, a digital volt ohm meter. So let's go ahead and remove this guy. Looks like there's already one screw missing here because somebody was probably too lazy to put it in, given that it's very difficult to access there. That's lovely. So we'll go ahead and remove these other bolts that are holding this on. Looks like we only got 3 of them holding it on there. And then we have one bolt on the front here that is basically a support strut between the starter and the alternator itself. We'll go ahead and remove all that stuff to free up our starter. Now, before we get too far ahead of ourselves here with the starter motor removal, let's talk about just recapping. I know we talked about this before in earlier videos when we were tearing this whole Cherokee apart. Let's talk about the flow of electricity. So from the battery, I turn the master switch on, I press the starter button here, it makes the starter spin and the engine turns. What kind of magic is happening there? Well, normally where the propeller is now located would be the battery. Now, the battery is going to always be supplying power right to the master switch and right to the battery solenoid, ready to go for when you turn the master switch on and close that connection. You're then going to be supplying electricity to the coil inside the battery solenoid, which will then generate a magnetic field, closing the circuit, connecting that big switch inside the battery solenoid to connect that switch and then supply power to the main bus, your primary bus. So we can see now power is flowing to the main bus. Power is also flowing to the start button and ready to flow to the starter. As soon as we press that start button, we're going to supply power to that coil inside the starter solenoid, and that's going to generate a magnetic field, closing that big circuit, allowing a large flow of electricity to flow to the starter motor. Now, that is what we see here with these 2 big wires, is the large amount of electricity ready to flow to the starter, and then that little tiny skinny wire is what is going to supply power to create that magnetic field from the starter button to then close the circuit between those 2 big heavy wires and allow a lot of power to flow from the battery to the starter motor to start your engine. Now let's show you what happens with that starter motor, that electric starter, when it gets 12 volts. So with our super fancy car jump box here, I'm just going to go ahead and ground myself off. Well, easy to ground myself off right to the engine here. So I'll just ground myself right off to the crank. Hopefully that'll be a good contact point for us. And I'll go ahead and connect my 12 volt positive right there. And what's going to happen when I supply 12 volts and turn this switch to on? This guy should jump out and spin. Remember, it jumps out, so it actually comes out of there to reach and interface with the ring gear. So we would have our ring gear here, that actually comes out and interfaces with the ring gear and then spins the ring gear. That will then get the engine started turning. Now, a couple of failure modes here. We could have this guy actually stick out and continue running in there. That's when you hear all that gear noise when you let off the starter. Occasionally, these get a little kind of sloppy and corroded and they don't always return where they're supposed to. Let's go ahead and watch how this guy works. So you see how he pops out and turns. Don't get your fingers anywhere near that. That's a lot of force right there. That will really do some damage to you. Me turning this little switch here on this jump box is the exact same thing as pressing this start button right here. So that is what's happening when we press that start button, because we're getting the 12 volts to here, which connects this big wire to this big wire, closes that switch, and supplies the 12 volts right through this wire, which we are artificially doing with our jump box there. Let's go ahead and take apart that starter solenoid so you guys can actually see what is going on inside here. There we are. Just by loosening that one, it was able to slide out the top there. So this is our starter solenoid. Let's go ahead and cut into this guy and see what it looks like on the inside. Now, before we cut into this guy, what we're gonna do is go ahead and hook up our ground wire here. I just want you guys to hear what's going on. Hooking up the ground there. Of course, this is grounded just by being bolted to the airframe. We saw where that grounding strap was going to ground the airframe, ground the engine to the airframe, all that stuff. Then of course, our ground or neutral side of the battery hooks to the airframe itself. So that's where our ground goes. And then our positive, this is the same as that wire coming in from our starter switch. So when we push that starter button, that starter switch, then that would close the circuit. And when I clamp on here and go ahead and supply 12 volts, you will hear this solenoid close. This is just nothing more than a big giant switch. So supply 12 volts, you hear the click. Let off, you hear it unclick. So pressing the starter button now, press, let go, and it undoes it. So what's happening? It's just connecting this terminal to that terminal, all right? So now we have our starter solenoid kind of opened up. It's a bit of a mess. We made one little cut there so you guys could take a peek inside of what is inside there. What is inside here is a bunch of metal windings. So just copper wire wrapped around a whole bunch of times. Why would they do that? Well, it's actually connected to this little terminal here where we have our 12 volts coming in of low current, low amperage, 12 volts coming in right here from that starter button. So we supply 12 volts there. It flows right through there. We can see where it's connected to those windings from this little stud here, that terminal. It flows through all those windings a whole bunch of times around in a circle, and then eventually makes its way to ground and passes back through the airframe. So we have flow of electricity, and that creates a magnetic field, all right? So that flow of electricity around all those windings creates magnetism. So this turns into a magnet. What does that magnet do? Well, it pulls down on this guy right up here, so you can see this big washer up here, and that is that clicking noise we were hearing. So, oh, there it goes. When we have that magnet engaged down here, it pulls this washer down between these two terminals. So we can see where we had power coming in, power going out, or rather power coming in up here, power going out there, not like it really matters all that much. And ultimately, when this washer gets sucked down by that electricity, then it closes the circuit and supplies power to our starter. So the spring keeps this open, keeps the circuit open, so there's no connection. And then when we create that magnetism by supplying 12 volts there, it pulls that washer down and closes the terminals, between those two terminals, closes the gap and allows electricity to flow from this terminal out to that terminal and through this big heavy wire on over to our starter motor. So that is, with a little bit of dirt and junk in there, that is what our starter solenoid is. We can see that there's a little bit of separator down there, a little rubber O-ring that separates the magnet down here from the top end up here. And that clicking noise was just this little washer up here clicking and smacking around in there, either clicking down or smacking back up against the roof or the top there that we cut off so you guys could see down inside this starter solenoid. So that is all there really is to it for the starter solenoid. We're gonna go ahead and take a little break here, by the way, because this is already getting pretty in-depth and pretty long. If you guys do enjoy this type of video, definitely let us know, leave it in the comments below. We've got a lot more instructional videos to make on this engine, but we wanna know what you like and what you don't like and what you wanna hear about. So please tell us in the comments below if you wanna learn about the exhaust, the fuel system, the fuel pumps, magnetos, how all those things work. We are going super in-depth into all this stuff. Let us know what you think. Let us know your feedback on this video right down there. Be sure to subscribe over there and hit that little bell so you get notified when we post more engine videos like this, and give us a thumbs up if you would. That always helps and we really do appreciate it. Be sure to tell your friends. The best compliment you can give us is referring us to your friends out there. We really do appreciate that stuff. As always, guys, if you cannot fly every day, then fly 8 Mike